Good morning, my dear students. Today I am describe the Laplace transform. Actually, generally Laplace transform used for signal system, and it's converts to time domain to frequency domain. Let the Laplace of ft is equal to 0 to infinity e to the power minus pt ft dt is equal to f of p, where t be the independent variables which is always greater than or equal to 0, where t be the independent variable which is t is greater than or equal to 0, and p be the any parameter which is real or complex. Actually, Laplace transform the mainly use to convert to time domain to frequency domain. Let us consider in the flowchart Laplace transform is converts time domain to frequency domain, right? And generally used in signal system. Now we are going in some property of Laplace transform. Just like the Laplace transformation of 1 is equal to 1 upon p, that is the function of p. And the second property is the Laplace transformation of t, that is 1 upon p square. This is also the function of p. And third property is Laplace of t to the power n, that is gamma n plus 1 upon p to the power n plus 1. And here n is greater than or equal to 0. And the fourth property is the Laplace transformation of e to the power at is equal to 1 upon p minus a. And the next property is the Laplace transformation of sin at is equal to a upon p square plus a square. And the Laplace transformation of cos at is equal to p upon p square plus a square. This is the important properties of Laplace transform. Also we can find the another property of Laplace transform just like this. The Laplace transformation of sine hyperbolic at is equal to a upon p square minus a square. And the Laplace transformation of cos hyperbolic at is equal to p upon p square minus a square. This is the eighth property, simple property of Laplace transform. Now we are going to some examples for this property, just like find the Laplace transformation of root t plus 1 upon root t, that is the Laplace transformation of t to the power 1 by 2 plus t to the power minus 1 by 2. We know that the formula of the Laplace transform is the Laplace t to the power n is gamma n plus 1 upon p to the power n plus 1. That is gamma 3 by 2 upon p to the power 3 by 2 plus gamma 1 by 2 upon p to the power 1 by 2. Therefore, this is the 1 by 2 root pi upon p to the power 3 by 2 plus root pi upon p to the power 1 by 2. This is the function of p. This is the answer for root t upon 1 plus root t. Because gamma n is equal to n minus 1 factorial n minus 1. So gamma 3 by 2 is equal to 1 by 2 into gamma 1 by 2, and 1 by 2 and gamma 1 by 2 is equal to under root pi. Now the another example of that is sin square t. Now we will change sin square t in the form of cos 2t. That is Laplace of 1 minus cos 2t upon 2. That is 1 upon 2. The Laplace of 1 minus cos 2t. Therefore 1 by 2. The Laplace of 1, that is 1 upon p. And minus cos 2t is p upon p square plus 4. This is the function of p, and this is the answer of sin square t. Now we are going to some another property of Laplace transform, just like first shifting property of Laplace transform. If the Laplace transformation of ft is equal to 0 to infinity e to the power minus pt, ft dt is equal to f of p, then the Laplace transformation of e to the power at ft is equal to fp minus a. This is the important rule for this property. Suppose, for example, the Laplace of e to the power minus at sin 2t. Here, first of all, we will find the Laplace transformation of sin 2t. That is the Laplace of sin 2t, that is 2 upon p square plus 4. This is the function of p. Now, the Laplace of e to the power minus at sin 2t, that is the function of p, will be p plus a. Here the function of p is 2 upon p square plus 4, that is p plus a. It will be p plus a to the whole square plus 4. This is also the function of p. This is the important rule of first shifting property. Now the another property, another example of this theorem, just like this: e to the power minus t sin 2t plus cos t plus t square. Now we will find first of all sin 2t plus cos t plus t square. That is sin 2t will be 2 upon p square plus 4, and cos t will be p upon p square plus 1, and t square will be gamma 3 upon p cube. This is the function of t. Now suppose this is ft and this function will be function of t. That is ft is equal to 2 upon p square plus 4 plus p upon p square plus 1 plus gamma 3 upon pq is equal to function of p by the first shifting property. That is e to the power minus t f of t is equal to p plus 1. Then the Laplace of e to the power minus t and ft is sin 2t plus cos t plus t square. That is replace of p in the form of p plus 1. That is 2 upon p plus 1 to the whole square plus 4 plus p plus 1 upon p plus 1 to the whole square plus 1 and gamma 3 upon p plus 1 to the whole cube. This is the condition for first shifting property. Now the second property, that is the second shifting property of Laplace transform. Here the Laplace transformation of ft is equal to 0 to infinity e to the power minus pt ft into dt is equal to f of p, and gt is equal to the function ft minus a and 0. For t minus a, that is t is greater than a and less than infinity, and 0, that is t is greater than 0 less than a. Then the Laplace of gt will be e to the power minus ap and f of p. For example, find Laplace of ft, where ft is equal to sin t minus pi by 2. Here t is greater than pi by 2 and less than infinity, and 0, t is greater than 0 and less than pi by 2. This is the case of second shifting property, because pi by 2 is the shifting case. Here, first of all, we will find the Laplace transformation of sin t. That is, sin t is equal to 1 upon p square plus 1. That is the function of p. Then, by the second shifting property, that is Laplace of ft is equal to e to the power minus ap into f of p. That is e to the power minus a. A is pi by 2 and p into fp is 1 upon p square plus 1. This is the example of second shifting property.